Okay, so last time we talked about reference angle and reference triangle. So today we will define trig functions in the xy plane. Okay, in the xy plane. So for any point in the xy plane, we can make a right triangle, right? So imagine this is the terminal side of the triangle, of the angle, and this point x comma y. So we make the reference right triangle by drawing this vertical line, right? So now what x means, so x means this bottom side and y means this head, the vertical side. So the angle theta is here. Okay, the angle theta is here. So if we use the definition of trig functions in the right triangle, okay, so what's the opposite side of theta? Is this y, right? What's the adjacent side of theta? Is x. Okay, is x. And what's the hypotenuse? Okay, what's the hypotenuse? Is the distance between the center 0, 0 and the point xy. Okay, the point xy. So we use letter R stand for this distance. Okay. So in the first lecture of the trig part, we already know the distance is x2 minus x1 squared plus y2 minus y1 squared, and then take a square root. For this special case, this is x squared plus y squared, and then take square root. So that's the length of the hypotenuse. Okay, this is hypotenuse. Okay, this is hypotenuse. Okay, so now we can use the definition of trigs, right, in the right triangle. So what is sine theta? Is opposite over hypotenuse, so is y over r. Cosine theta is adjacent over hypotenuse, so is x over r. And tangent is opposite over adjacent, so this is y over x. Okay, and you flip them, you get the other three. Okay, you get the other three. Okay, yeah, so now you have to remember three more new definitions for any points in the plane. This is the trig value. Okay, this is trig value. Flip these three, you get the other three. Okay, you get the other three. Okay, so now let's look at our first example. Okay, our first example. So suppose the point is 3, 4. Okay, the point is 3, 4. So 3 is x, 4 is y. So let's first draw the picture. Okay, draw the picture. Make a right triangle in the plane. Okay, in the plane. Okay, so 3, 4. So we go this 3 and then go up 4. Okay, so now this is the terminal side of the angle theta. Okay, the angle theta. So x is 3, y is 4. This point is 3, 4. Okay, yeah. So now opposite of theta is y. So this is number 4. Adjacent is x. This is number 3. And what is r? What is r? This is one of our special right triangles. 3, 4, 5. So r is 5. Okay, r is 5. So if you forgot r is 5, you can use Pythagoras theorem, right? So r is 3 squared plus 4 squared, and then take square root. Then you got number 5. Okay, then you got number 5. So now sine theta will be y over r. So this is 4 over 5. Cosine theta is x over r. So this is 3 over 5. And tangent is y over x, so this is 4 over 3. Okay, 4 over 3. Okay, so this is 3 comma 4. Okay, 3 comma 4. So now if this is, let's change one of them to negative number, right? Let's change this to 3 negative 4. Okay, so if the point is 3 negative 4, again we need to draw this reference right triangle, right? So 3 negative 4 is somewhere here. Okay, so we go this side is 3, and then go down 4. So x is 3, y is negative 4. Okay, negative 4. So here, negative just means go down 4. Okay, go down 4. It's the direction. Okay, it's the direction. Okay, so this is the angle theta. And this angle is the reference angle alpha. Okay, reference angle alpha. So now what's the opposite side? Y, right? So sine theta is y over r. So the hypotenuse is also r. So this is 3, 4, 5 again, right? 3, 4, 5 again. Okay, so this is negative sign, just means we go down 4 units. So the length here is 4, length here is 3, so the hypotenuse is 5. Okay, 5. So we got negative 4 over 5. Cosine theta is x over r, so this is 3 over 5 positive, and the tangent is negative 4. So let's write down the definition. Tangent is y over x. This is negative 4 over 3. Okay, that's 3. So for this example, let's also write on the other 3, right? So you flip sign, you got cosecant. So this is r over y, so it's 5 over negative 4. Flip cosine, you got secant. You got r over x, so this is 5 over 3. And then flip tangent, you got cotangent. So this is x over y, so this is 3 over negative 4. Okay, 3 over negative 4. Okay, yeah, so this is the definition for the trig functions of a point x, y in the plane. Okay, x, y in the plane. So now some special case, right? Some special case. So let's say if p is 2, 0, the point is 2, 0. So x is 2, y is 0. What is r? R is square root of x squared plus y squared. So this is square root of 2 squared plus 0 squared is square root of 4. So r is 2. Okay, r is 2. So now let's look at the sine and cosine. For this case, we cannot draw the triangle. Okay, we cannot, there's no right triangle. So 2, 0 is here, 1, 2. So you see when you draw a vertical line passing through number 2, there's no right triangle because the terminal side is the initial side. There's no rotation. Okay, there's no rotation, so there's no acute angle. Okay, so now the sine theta for this case is y over r, so it's 0 over 2 is 0. Cosine theta is x over r, so it's 2 over 2 is 1. And tangent theta is y over x, so this is 0 over 2 is 0. So what's the angle theta? Okay, what's the angle theta? Theta is 0 degree. Okay, so terminal side, P is on the terminal side. P is on the terminal side of the angle. Terminal side is the initial side, so the rotation is 0. Okay, rotation is 0. Then we got sine 0 degree is 0. Cosine 0 degree is 1. Tangent 0 degree is 0. Okay, it's 0. So let's try this one more time. Okay, one more time. Okay, so now let's say if we have another point is 0, negative 2. Okay, so x is 0, y is negative 2. So what is r? R is square root of x squared plus y squared. This is square root of 0 squared plus negative 2 squared. So r is 2 again. Okay, r is 2 again. So let's draw the picture. Where's my point P? My point P is here. Go down, negative 2. Okay, go down negative 2. So now P is on the terminal side. Okay, P is on the terminal side. We know this is the angle theta. Okay, so our theta is 3 pi over 2 or is 270. Okay, 270. So sine 3 pi over 2, it will be y over r is negative 2 over 2, negative 1. Cosine 3 pi over 2 is x over r, so is 0 over 2 is 0. And tangent 3 pi over 2 is y over x, so this is negative 2 over 0, so this means undefined. Okay, so this ratio is undefined. Okay, undefined. Okay, so now we have a special case, and then the tangent is undefined. So for this case, you cannot get a right triangle. Okay, there's no right triangle if the point P is on the 4-axis. Okay, yeah. Okay, so if you know a point on the terminal side, then you use x, y, r, and you use the trig definitions, you can find the trig values. Okay, trig values. So now if you're only given the angle, given theta, then we need to find this point P, and then use x, y, r to find trig value. Okay, trig value. Let's look at our example, two examples, right? So first, theta is, let's say, pi over 3. Okay, pi over 3. So this is also 60. If you don't know what's pi over 3, change it to degree, right? Degree measure. So this is the terminal side. Here is our angle. Theta is 60 degree. Okay, 60 degree. So where is our point P? You can choose any point on the terminal side. Okay, yeah. And then draw the line, and then label this is 30. So it's our special 60-30 right triangle. So now we know the length of opposite side, right? Opposite of 30 is 1. Opposite of 60 is radical 3, and then hypotenuse is 2. Okay, hypotenuse is 2. So now what is this point P? This point P is x is 1, and y is radical 3. Okay, radical 3. And then we also know the hypotenuse is 2. Okay, hypotenuse is 2. So this is x, this is y. Okay, this is y. Then we know sine of pi over 3 is y over r. So it's radical 3 over 2. Cosine pi over 3 is x over r, so 1 over 2. Tangent pi over 3 is y over x, so this is radical 3 over 1, and it's radical 3. Okay, radical 3. That's the easiest case. Okay, that's the easiest case. So now let's suppose theta is negative pi over 3. Okay, it's a clockwise rotation, and then rotate this way 60. Okay, this way 60. So again, we need the point on the terminal side, draw the vertical line to find the right triangle. Okay, so this is the reference angle is positive 60. So theta is negative 60. The reference angle is 60. Okay, it's 60. And then this is 30-60 triangle again. Okay, 30-60 triangle again. So opposite, here is 1. Here is negative radical 3. Okay, so the y is negative radical 3 is not positive because it's going down radical 3. R is 2. Okay, R is 2. So R is always positive. Okay, R is always positive. So x is 1. Y is negative radical 3. R is 2. And then we can use results to write down the trig value. Okay, trig value sine negative pi over 3. So this will be y over r. So this is negative radical 3 divided by 2. Okay, cosine negative pi over 3. So this will be x over r. So it's 1 over 2. Okay, it's 1 over 2. So these are the cases. The second case. Okay, you are given the angle. Okay, you are given the angle. Okay, so now special case, so if this is pi over 2. So pi over 2, this is the rotation, theta, 90 degree. So you need a point on the terminal side. So terminal side is positive by x-axis, so you just choose 1 here. Okay, so you got x is 0, y is 1, and then r is 1, because r is square root of x squared plus y squared. Or r is the distance from this center 0, 0 to the point xy. Okay, point xy. And then you use sine 90 is y over r, so it's 1 over 1, 1. Cosine 90 is x over r, so it's 0 over 1, 0. Okay, 0. So now we know two cases. You are given a point, and you are given an angle. Okay, given an angle. Okay, given a point, draw the reference right triangle. Given the angle, draw the reference right triangle. The reference right triangle is the most important thing. Okay, it's the most important thing. Okay, so now the last case, you are given one of the trig value and more information about the position of the terminal side. Okay, terminal side. So that's our last case. Okay, that's our last case. So let's say we got sine theta is, let's say is 1 over 2, and the theta is in the second quadrant. Okay, second quadrant. So the most important thing is we draw the picture. Okay, we draw the picture. So this is our angle theta. Okay, our angle theta. And then we make the reference right triangle. Okay, right triangle for this angle theta. So there, the acute angle inside here is alpha. Okay, is alpha. Okay, so now we have to use the definition of sine, right? So this point is xy. Hypotenuse is r. So sine theta is supposed to be y over r, and is given 1 over 2, so this is 1 over 2. Okay, and then we can assume y is 1, r is 2. Okay, r is 2. Maybe there are multiples of 1 and 2, but here we don't know. We can choose any point xy on the terminal side, so the easiest way, we just choose y equals to 1, r equals to 2. Okay, so positive case is easier. Okay, positive case is easier. If it's negative, you have to choose y to be a negative number. Remember, r is always positive. Okay, r is the distance, so it's always positive. Always positive. Okay, so now r is 1, y is 1, r is 2. If you remember our special case, so x will be negative radical 3. Okay, so the length here is radical 3, so this is radical 3, but it's to the left, so it's negative radical 3. Okay, so this implies x is negative radical 3. Okay, if you remember, this is 1 to radical 3 right triangle. So if you didn't remember, you can use x squared plus y squared is r squared. So we got x squared plus 1 is 4, r is 2. So x squared is 3, so we got x is radical 3, or x is negative radical 3. So based on the picture, x is negative, so you delete positive. Okay, delete positive. You got x, y, and r, then you can write down sine, cosine, and tangent. We already know sine, so let's just write down cosine. Cosine will be x over r, so it's negative radical 3 over 2. And tangent theta is y over x, so this is 1 over negative radical 3. Okay, so this is the hardest case, the last case. Okay, the last case. You are given the one of the trig value and the position. Okay, and the position of the angle. Okay, so now let's find, so let's say tangent theta is negative 1, and the theta is in the fourth quadrant. Theta in fourth quadrant. Okay, so let's draw the picture. So the angle is here. That's our theta in the fourth quadrant. And this is the right triangle. We choose this point xy. And then we draw a vertical line to make the right triangle. So this is x, this is y, this is r. Okay, so x, y, r is the right triangle. Okay, so now tangent is negative 1. So what's tangent? Tangent is y over x. So we could choose, they're both number 1, right? Y is 1, x is 1, then the ratio will be 1. One of them is negative. So look at the picture. This is positive, that is negative. Okay, so y is negative 1, x is positive 1. Okay, so they cannot be both positive 1. So you can choose 2, negative 2, 3, negative 3. Okay, so the most important thing is based on the picture, y is negative, x is positive. Okay, so that's why we need this information about the terminal side. It tells us which one is positive, which one is negative. Okay, so now what's r? So r is square root of x squared plus y squared. So this is square root of 1 plus 1. So r is radical 2, always positive. Okay, r is always positive. And then we are ready for the trig value, right? So sine theta is y over r, so it's negative 1 over radical 2. And cosine theta is x over r, so it's 1 over radical 2. Okay, 1 over radical 2. And tangent is given. Okay, tangent is given. Okay, so this is the most important thing. So I already gave you the picture in the second quadrant for this example, in the fourth quadrant for that example. So now let's look at easier case, the first quadrant. Okay, the first quadrant. So let's say cosine theta. Let's use cosine now. Cosine theta is 1 over 2. Okay, 1 over 2. And the theta in the first quadrant. So this is my angle theta. And we know is cosine is x over r. So x is 1, r is 2. Okay, so based on the picture, this is xy, the point on the terminal side. Then we know this is positive. This is also positive. Okay, they're both positive based on the picture. Okay, based on the picture. And then what is y, right? What is y? X squared plus y squared is r squared. If you don't remember, it's 1 radical 3, 2. A special right triangle. Use Pythagorean theorem. So 1 plus y squared is 4. Y squared is 3. So y is positive radical 3, or y is negative radical 3. So the picture gives us positive. Okay, positive. So this is x, y, and r. Okay, and r. Then we know sine theta is y over r, so it is radical 3 over 2. And tangent theta is x over r, so it's y over x, sorry. So it's radical 3 over y, so radical 3. Okay, radical 3. And then from this special triangle, we also know the theta is 60. Okay, theta is 60, opposite to the radical 3. Okay, radical 3. Okay, so that's the 3 kind of problems that we may need for the reference right triangle in the plane. Okay, in the plane, and the trig values. Okay, trig values. So now in the end, so let's write down the 6 trig definitions again, right? We need point P and R distance between 0 and P. Okay, distance between 0 and P. So this is the distance between the 0, 0 and the point P. Okay, point P. So what is sine theta? Sine theta is P is on the terminal side of theta. Okay, so sine theta is y over r, that's definition. Cosine theta is x over r. And the tangent theta is y over x. So the picture looks like this. This is x, this is theta, this is y, this is r. Okay, so opposite is y, adjacent is y, adjacent is x, and the hypotenuse is r. And then we flip them. You got cosecant is r over y, and this one you flip, you got secant is r over x, and the last one you flip, you got cotangent is x over y. Okay, x over y. So this is the trig functions in the plane. Okay, trig functions in the plane. Okay, so that's it. That's our today's lecture.